Hi, my name is Sebastian Matteau, and in this video today I would like to take a look at set comprehensions in Python. Now this is the third video in a series about comprehensions in Python. We've previously looked at list comprehensions and dict comprehensions. And today we're going to see how we can apply that logic to set comprehensions. Now first things first, what is a set? A set in Python is an implementation of set theory, you could say. A set is a collection of unique items without any particular order. So it's kind of like an unordered bag of elements, and every element in a set is unique. So you cannot, for example, have the number 1 be part of the same set twice. Now, set theory is a branch of mathematics that has all kinds of convenient mathematical purposes, which I'm not really going into. But because Python has such a strong background in mathematics, a set is one of the built-in iterable types in Python. Now, what are we going to do today? We're going to see how we can apply comprehensions to sets using set comprehensions. And the goal that I've set out for myself is quite simple. What we want to have is a set of numbers between 1 and 100 that are both prime and part of the Fibonacci series. Now, so here we have a function that I've defined that checks whether something is prime or not. And it actually secretly uses a generator expression that we're going to take a look at in the next video in more detail. But basically what this function does, it takes a number I, checks whether it is prime, returns true if it is, and returns false otherwise. And we have another function isFibonacci that similarly takes a number I, checks whether that number is part of the Fibonacci series, returns true if it is, and returns false if it is not. If you find it interesting to see how these functions work, take a good look at them and try to figure out how they are actually implemented. But for now, just see them as simple checkers of whether a particular number is prime or is Fibonacci. And then I have defined a constant, which is simply the range of numbers between 1 until and including 100. Now, say that we wanted to get a set of numbers between 1 and 100 that are both prime and Fibonacci, but we're not going to use a set comprehension to do that. Then there are many ways essentially in which we could do that, but one way is, for example, something like this. We would create an empty set of primes, I will call it primes, and I say set. Now a set in Python is defined with curly braces, just like a dictionary, so there is some syntactic confusion between the two. If you use curly braces like this, you actually are not defining an empty set, but an empty dictionary. And if you want to define an empty set, you have to explicitly say set, like this. And we're going to create an empty set of Fibonacci's. And then we're going to loop through all our numbers for I in numbers. Up. Oh wait, let me load in this. Up. For I in numbers. And then I simply say, okay, if this number, if is prime, I, then I'm going to add primes.add. So add is the method of a set object that adds a particular element to that set, just like append appends an element to a list. Add adds an element to a set. Add I. If the number is part of the Fibonacci series, I will add it to the Fibonacci's. Add I. Now then I end up, of course, with two sets, one of primes and one of Fibonacci's. And then I'm going to take the intersection between the two. What is the intersection? Well, an intersection is an operation that you can do on sets, and it gives you a new set that includes all the elements that are in both of the original sets. Right? So you have, for example, the union, that is kind of like an OR, where you get all the elements that are either in one set or in the other or in both. And the intersection is the set of all elements that are actually in both sets. So that's what we want here. So I can say s.primes and Fibonacci's. What is the AND? The AND is the built-in operator into Python that actually gets you the intersection. Print it out, print s. Okay. So all those numbers, 1, 2, 3, 5, 13 and 89, are both prime and Fibonacci. This is not so difficult, right? This is a traditional for loop. We're looping through all the numbers, we're checking if they're prime, then adding it to a set of primes, checking if they're Fibonacci, adding it to a set of Fibonacci's, and then we create a new set that is the intersection of both the primes and the Fibonacci set. So that is the set of all numbers that are both prime and Fibonacci. Now, that is a regular for loop. How can we do this with a set comprehension? Well, there are again a few different kinds of solutions, but I just want to illustrate the basic principle of a set comprehension, and it goes as follows. We indicate with curly braces that we're going to have a set comprehension. This is not ambiguous with the dict comprehension that also uses curly braces, because in the dict comprehension you always have a column that indicates that you have a key value mapping. You don't have that in a set, and that allows Python to know whether you're actually referring to a set comprehension or a dict comprehension. So we define a set comprehension with curly braces. Okay, now what would be the set comprehension? There is always a loopy part in the comprehension, right? So for I in numbers. Let's say that this set is going to be assigned, is going to be the set of primes. Then I say I for I in numbers, if is prime I. And I assign that to primes. So this is a set comprehension. It checks whether a given number is prime, loops through all the numbers in I, and then just gets the set of all those numbers. It doesn't apply any kind of operation on that number. We could, right? We could, for example, do something with I here if we wanted to, but we're not going to do that. And the resulting set from the set comprehension is assigned to primes. And we can do the same thing for Fibonacci, so I'll just copy it. The only thing that we need to change is if Fibonacci, and then we assign it to Fibonacci's. Then we have a set of primes and a set of Fibonacci's. And in exactly the same way as we did before, we can get the intersection of these two sets, primes and Fibonacci's, and we can print it out as. Right, so here we have the exact same logic that we have here above, but expressed using set comprehensions. Of course, we could have done it differently too, right? Another way in which we could have done it, for example, is to have, instead of saying if is prime, we could say if is prime and is Fibonacci, and then use only a single set comprehension. So there are different kinds of solutions to this particular problem, but I just wanted to show you the general syntax of a set comprehension. So a set comprehension uses curly braces, just like a dict comprehension, but a dict comprehension has a colon indicating a key value mapping pair here. A set doesn't have that, and that is why Python knows that this is a set comprehension and not a dict comprehension. Just like every comprehension, there's always a loopy part for I in numbers. There's this optional filtering part, if is prime, and then the elements of our new set. Right? So if you've seen the previous videos about list comprehensions and dict comprehensions, you will see that this is actually very similar. Now, with that, thank you very much for your attention. In the last video, the next video about comprehensions, we're actually going to take a look at generator expressions, which are a very interesting form of comprehensions in Python. Thank you very much for your attention.